Howdy, folks. Big things popping, little things stopping. Wazakowski here, starting off chapter 10. In this very first section, we are going to look at some special pairs of lines and angles. Should be a nice, quick, easy lesson here. Just going to be identifying some things. Your goal is to be able to obviously identify them within a diagram so that we just can familiarize ourselves with some of these things. So let's jump right into it. So first thing we're going to look at is probably a term we've talked about before a couple times throughout the year is parallel lines. So guys should probably be pretty familiar with parallel lines. We're just going to get a little sassy with the geometry jargon that we're going to use. So two parallel lines, again, are going to be two lines that do not intersect. Specifically, parallel lines are going to be two lines in the same plane that do not intersect. So I'm going to draw it for you guys first. But again, a plane, think of a plane as almost like a sheet of paper, like a floor surface that we're going to deal with. So I'm just going to draw here just a plane just so we can recognize that parallel lines are lying within the same plane. And parallel lines, again, are not going to intersect. So let's say that I have one line that goes left to right. I would have a second line that would also go left to right, meaning that they go technically in the same direction. We did talk about parallel lines when we looked at the idea of slope, that parallel lines have the same slope, and that is why they do not intersect. So those lines are said to be parallel because they do not intersect. On a diagram, when we want to represent two parallel lines, what you're going to see are arrows drawn on the line. In this case, red arrows. Doesn't matter which direction they're drawn. It could be one arrow, it could be two arrows, but arrows are going to be used to show that those lines are parallel to each other. Okay, how do we label parallel lines? So anytime we name a line, we can use a lowercase letter, like, for example, M and N. So I can write that two lines are parallel by saying that line M is parallel to N. And what I'm going to use to represent parallel are two vertical lines like that. Those two vertical lines are going to represent that those two lines are parallel. So I can use the lowercase letters, but the key idea here is that this symbol right there is used to represent parallel lines. If I were to use, let's say, the points on my line, so say this is A and B, and this is C and D, I could say that AB as a line with the line written above and CD with, again, the line written above. If I want to show that those are parallel, I just have to use those vertical bars. So these vertical bars are the way we're going to label parallel lines when we have to write things out, when you see things written in problems. So parallel lines, again, are something that we should hopefully be familiar with at this point. However, parallel lines are not the only type, I guess, of parallel lines. There are another type of parallel lines called skew lines. Skew lines are technically parallel lines in that they do not intersect. But sometimes you could have lines that don't intersect that are not in the same plane. Now, this is a little bit tricky to understand. So again, what I'm going to do is I'm going to draw this first. I'm going to do some gypsy voodoo stuff right now, okay? I'm going to draw for you guys a box. Okay, and if you guys know how to do this, whoop, I'm going to draw it as best as I can. That's kind of sloppy, okay? Now, why I wanted to draw a box is because a box has many different lines drawn on here. So to show you guys, let's say that I have a line drawn right here, that kind of top edge of the box. And let's say that I have a second line drawn right here, say the front corner of the box, okay? Now, those two lines will never intersect each other, okay? The side of the box that's on the top left as I'm viewing of it will never intersect the front right edge of the box. So those lines technically don't intersect. However, they do not lie in the same plane. The red line lies in the plane of the top of the box, and the blue line lies in the plane of the front of the box. So because they lie in completely different planes, they are said to be skew. So skew and parallel are very similar. The difference is that they lie in different planes, okay? Now, in terms of the label for skew, you're not going to see anything special. You will just see the word skew being written. So again, if I were to fit labels to this and say that this was line M and this is line N, you would just see that line M and N are skewed. No sassy symbol there for skew lines. Okay, next thing's parallel planes. So just like parallel lines, we can have parallel planes. And parallel planes are just like parallel lines in that they're two planes that don't intersect. So to help you guys visualize this, I'm going to draw it first, okay? So I'm going to draw a little box again, but I'm going to try and make this three-dimensional as best as I can. All right, so I'm just going to connect my corners here. All right, the ones that I can see, I'm going to make bold. And then there's one corner here in the back. I'm just going to leave dash. So think of this as like a cube. I just want you to see all three planes here. So parallel planes would be, again, two planes that do not intersect. The best way to kind of describe this is think of like a room. All of you are probably sitting into some room right now watching this video. So think of a plane as like a wall or the floor or the ceiling. Which of those surfaces do not intersect with each other? There's multiple options here. So for example, I could say that the ceiling or the top of this box does not intersect with the bottom of the box. Those two planes are said to be parallel. Now again, that's just one choice. I could have chosen the left side wall and the right side wall. I could have chosen the front and the back wall. There's many different options when I look at the parallel planes, okay? So again, it's any two surfaces that don't ever intersect. Now, how do we label this? Again, anytime you label a plane, it's always based off of 3 points, at least 3 points. So let's say that I had my top surface, I'll just label A, B, C, D, and my bottom surface, I'll say E, F, G, and then H, that back corner. So what I would say when I'm using parallel again is anytime I use parallel, I'm going to use the vertical bars like I showed before. So I would say here plane ABC is parallel to plane EFG. That's plane EFG. So I'm going to still use my parallel symbol to represent planes. It's just, again, planes, we're going to use 3 letters instead of lines where we'd use 2 letters. So parallel planes, parallel lines, skew lines, all those things are things that don't intersect. Now, within this section, we are going to look at special lines that do intersect, but I do want to bring back a special type of line that we did talk about earlier this year called perpendicular lines. So yes, sometimes lines don't intersect. They're either parallel or skew. But sometimes when lines do intersect, they intersect at special angles. And a perpendicular line is a special type because they intersect at our favorite angle, which is a right angle or 90 degrees. So just keep in mind that perpendicular lines are, let's say that I have a line that goes left to right, call that line M, and then I have a line going in the complete opposite direction, call that line N. If these lines are perpendicular, then the angle of intersection would be 90 degrees, okay? So that's a special angle, again, 90 degrees. That would be our perpendicular lines. Now, how do I label perpendicular? Again, I'm going to use my 2 letters potentially, so I can say line M and N. Now, parallel, we use those vertical lines. Perpendicular, we're going to use kind of like a capital T upside down, kind of tipped over. So that would be line M is parallel to N. Now, even though it's not drawn in there, again, I could use letters. So say line AB is perpendicular to CD. But this symbol right here, I think I might have said parallel on accident, I'm sorry. But this symbol right here is used to represent perpendicular lines. So these are some special types of lines and planes that we are going to look at. And again, our goal is to kind of look at the relationship formed within these things. Our first example is just identifying these, okay? So within this, A through D, I'm going to give you guys a little statement here. Our goal is to try and figure out which line, segment, or whatever it might be best fits the description. It might be one thing, it might be multiple. So first one, A, it says a line parallel to CD. So parallel means, here's CD. Parallel means that I want a line that does not intersect CD. So parallel, again, lines that don't intersect would be, for example, AB. I could say all the way down here, EF. I could say HG. Now, the key thing is that if they want to be parallel, they need to be in the same plane. So that leaves 2 options. I'm going to draw on here. That leaves me with A to B. And notice that both A and B and C and D are on that top surface of the box. And then E to F is technically also parallel to CD because it lies on the left side of the box. Now, the key thing here is that it wants to identify which of those goes through point A. So by doing that, I know then that the only option that would be parallel to CD that goes through A would be line AB. So again, parallel kind of went through the long version of that, but it has to be in the same plane, do not intersect, and then it gave that specific point it's going through. Okay, I'm just going to clear out my diagram here just so I can use it on the next couple problems. Looks like, there we go, can erase that. Okay, next one says I want to find a line skew to CD, and contains point A. So skew means they're going to be parallel again, but skew also means that they cannot lie in the same plane. So what that means is that eliminates AB. AB is not going to be skew. If we say AB is parallel, that means it lines in the same plane, so it's got to be, we're looking for one that's skew, so it eliminates that. So that means it gives us two options. If I look at A, the only points that or lines that go through it, would be A to D, A to B, A to G, A to H. So based on those options, there are two things that work. A to H, which goes up and down, that would be skew. And the reason why A to H would be skew is because it does not lie in the same plane as C to D. C to D, again, is on the left or top part, and this is going to be on the front or right side, completely different planes. Same thing is true for A to G. So A to G would be the line that goes through here. So A to G would also be skew. And again, A to G lies specifically on the right side. And the right side is not the same plane as the top or the left. So again, skew means that they're not going to intersect, but they're also not in the same plane. A little bit sassy there, folks, but classy at the same time. All right, next one says line perpendicular to CD and containing point A. So perpendicular means, babes, that we're going to intersect at 90 degrees. So if I look up here, which line goes through point A, that is going to intersect CD at 90 degrees, and I can obviously see it here, that would go through A to D. So I'm going to say line AD is going to be perpendicular to C to D. And then lastly, babe, we're going to look at then parallel planes. So it wants to know which plane is parallel to EFG and also contains point A. So I'll highlight this on here for you folks. EFG is going to be the bottom part of this plane. So which plane is parallel to the bottom? Hopefully you guys will all recognize it's the top. And notice that the top of that box contains point A. So what I would say here is that we have plane, and I can label this again with any three letters. So I will say A, B, and C, because that top part of the box contains those 3 points. All right, so this is just recognizing these different vocabulary words on a diagram. And again, it's extra practice in writing these things. All right, here's kind of a real-life example of these different types of lines. Specifically, we're going to look at parallel and perpendicular lines. So in A, it says, name a pair of parallel lines. So based on this diagram again, in a diagram, if we want to recognize two lines as being parallel, what we want to look for are those arrows. Remember, on a diagram, we're going to use those arrows to show that they're parallel. Now, we're going to be careful because sometimes, like on normal lines, we're going to use these arrows to show that the lines continue on and on forever. But when I try and identify parallel lines, I want to look for something like this. So notice that on this little ray that's formed technically from D to M, those two little arrows and these two arrows are indicating that these two are going to be parallel to each other. All right, so I'm just going to label those. So again, here, since they're only labeled with points, I'm going to use 2 points. So for this first one here, I'm going to label D and M, and then we have E and F. Now, if I want to get a little technical here, notice that this street starts at D and it goes through M and continues on. So technically, that's a ray. So the way I'm going to label this is starting at D, going through M. I'm going to do the same thing with E to F. And now to show that they're parallel, I'm going to use that parallel symbol. So DM is going to be parallel to EF. Next one in B, it says name a pair of perpendicular lines. So perpendicular lines means they're going to intersect at 90 degrees. So on my diagram, you're going to see that indicated here by that little box. That box is going to represent 90 degrees. So therefore, those two lines that are intersecting at point M are going to be my perpendicular lines. So I can see, for example, it's B to F. Again, there's multiple ways to label that, but B to F would be this line right here. Notice how this is a line because the arrows continue in each direction. So I'm going to label it as line BF. And then you'll see that that intersects right here with, I already used D to M, so I'll use it again. So D to M, and we already said that that was a ray. Now to show that they're perpendicular, I'm going to draw that upside down, capital T. So I know that B to F is going to be perpendicular to D to M. All right, now the last question, C, says, is F to E parallel to A to C. So again, line F to E, parallel A to C. So I'm just going to label these real quick. I'm going to highlight them for them so we could see. F to E would be this line right here, and A to C would technically be this line right here. And I want to know, are those two lines parallel? Okay, and obviously if you look at those two lines, okay, are they parallel? Well, parallel lines, again, don't intersect. Now this is where sometimes students get confused. If we think of this line right here as being a road, this road doesn't continue. So technically, those two roads aren't going to intersect, okay? However, that does not mean that they're not parallel. If they don't intersect, that does not mean that they're parallel. Okay, if we look at them, obviously, you can see that if I were to extend this line A to C, if I were to continue on, and if I were to extend E to F, eventually, those two things are going to intersect. So are these things parallel? No, and the reason why is because I'm going to say they will eventually, ooh, that's a fancy word, they will eventually intersect. Okay, so even though they might not cross at that what's shown in the picture, they would intersect if they were to continue as lines. That means they are not parallel. Sweet baby Jesus, we got more definitions here, shawties. Okay. So now, instead of looking at special lines, now we're going to look at special angles. So pairs of angles here. So to kind of introduce these angles, the angles are formed anytime two lines intersect. All right, so to kind of go back to when we introduced angles, anytime two lines intersect, angles are formed as the space between any two lines. Oops, I already used that color, but whatever. Okay, so those colors up there, those represent the angles. Now, we've already talked about some special types of angles. We've already talked about angles that are, God bless America in all of its glory, angles that are across from each other, such as this or those, that those are called vertical angles. Okay, we've already talked about them. We already talked about angles, too, that are next to each other, like the green and the red. And those angles are said to be adjacent. Heck, you could even say they're supplementary, if you will. That being said, we did talk about angles formed from intersecting lines. So what we're going to look at now is what happens when we have angles formed between special types of lines. To do this, we're going to introduce a new type of line called a transversal. So a transversal is going to be a line that intersects a line, but it's not just going to intersect one. A transversal is going to be a line that intersects two or more lines at different points. So for example, let's say that I have two lines, two random lines, say like this. Call this line M and N. A transversal is going to be a line that intersects both of those lines, and we'll label this T. They're going to intersect both of those lines at different points. So notice they're not intersecting at the same point. Okay, so for my transversal, think of my transversal as going to be line T. Now, when we do this, you're going to see a bunch of angles formed. Okay, and I'll highlight some of them. You're going to see, obviously, the 4 angles here and the 4 angles there. So what we are going to do is we are going to investigate some special relationships formed within those angles. So there are multiple different types. We're going to start off first with what are called corresponding angles. Corresponding angles are going to be two angles in the same position. The word corresponding means that you're kind of on the same page. You're at the same location, okay? So if I were to look at, again, and I'll kind of copy this diagram down. Let's say that I have, God bless America, let's say that I have line M, and let's say that I have line N with my transversal T. Corresponding angles would be in the same location. So for example, I'm going to give you one example here. Let's say that I have my angle here. The way I like to think about it is that at that intersection point, that angle, God bless it, that angle is at the top left corner. So if I go to the other intersection point, I want to identify the angle that's also in the top left corner. Okay, so those two angles would be considered corresponding angles. Now, that does not mean that they are the only ones. Okay, if I chose the top right, that would correspond to the top right. The bottom right would correspond to the bottom right. bottom left correspond to the bottom left. So anytime they're the same location, they're considered corresponding angles. All right, next one, we're going to look at what are called same-side interior angles. So if I were to, again, draw my two lines, so I'm going to draw line M, and I'm going to draw line N. I'm going to draw a transversal T. All right, same side interior. So same side interior, break this down. First of all, the word interior means that we want to be between the two lines. So in between the two lines, we have four angles, here, 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 and here. Same side means that they want to be on the same side of the transversal. So for example, I'm going to highlight. Let's say that I have here this one. Okay, that's on the bottom right-hand corner. They are between the two lines. So if I want to choose the other same side interior angle, it'd be one on the top right corner here. So these two would be considered same side interior angles. Opposite to that would be the ones across. So the ones in blue would also be same side interior angles because they are on the same side of the transversal in between the two lines. Now, opposite to same side interior angles are alternate interior angles. So again, if I were to draw my two lines, God bless America, if I were to draw line M and line N, and then I draw my transversal T, alternate interior angles means that they're not on the same side, but they're on opposite sides of the transversal. So again, I'm going to have four interior angles. I'm going to have the two that are at the intersection of my transversal and M, and the two here that are at line N. Now, same side interior means that they were on the same side of the transversal. So alternate means opposite. Now, the key thing here when we talk about alternate is I'm going to use a fancy word. They cannot be adjacent, which means they cannot be next to each other. So for example, if I were to choose one of these, so say I'm going to choose this one right here between line M and T. So adjacent means I do not want to choose the one next to it, but I want to choose the other one that's on the opposite side. So that's going to be at the intersection of N, but it's going to be on the opposite side. So here my alternate interior angles would be those, and here shown in green. So think of the colors there that I'm using, okay? So alternate interior means they are on opposite sides of the transversal, but also between line M and N. The key thing here is that they cannot be adjacent to each other. All right, and the last one here, we have alternate exterior angles. So just like before, I'm going to draw it out here. I got my line M. I have my line N. I have my transversal T. All right, so interior angles, we talked about them being between the lines. So exterior angles are going to be outside of the two lines. And again, the word alternating means opposite sides of the transversal. But key detail here, they are not adjacent to each other, which means they cannot be next to each other. So for example, if I were to just choose, let's say, this angle right here in the top left, okay, that is an exterior angle because it's not between the lines, it's on the outside. Now, alternate does not mean the one next to it. I can't have an adjacent angle. So what I'm going to do is I'm going to have to go to the other two exterior angles by line N. So again, below N, because it can't be in between, so it's got to be below, I have these two choices. So here, this one would be on the same side of my transversal. So what I'm going to look at is the angle right here. That is on the opposite side of the transversal. They are not between, but they are on the outside of the two lines, and they're also not adjacent. They are not next to each other. All right, so what we're going to do is we're going to look at identifying these special types of angles. So in this example, you have the diagram, and notice you have your two lines, and they're not really labeled, so if I were just keep it consistent with what I did, say this is line M, that's line N, and think of this one that cuts across T as my transversal. You are intersecting at two separate points, and notice there's 8 angles formed. It's kind of the neat thing about this is there's always going to be 8 angles formed. So what I want to know here, I want to know what are all the pairs of corresponding alternate interior, alternate exterior, and consecutive, or think of that as same side interior. So we'll start off first with corresponding. So corresponding means all the angles in the same location. So let's just start off with angle 1. Okay, so angle 1, and I'll just use angle 1 in a comma. Angle 1 is in the top left corner of this intersection. So if I go to the other intersection, angle 5 would be in the top left corner. So angle 1 and 5 would be corresponding angles. Okay. I also have then angle 2. Angle 2 is in the top right corner. So that would correspond to angle 6. Angle 6 is also in the top right corner. All right, then here we'll put a little colon or semicolon. One of the two. Continuing on, I can say angle 3. Angle 3 is in the bottom left-hand corner. So if I go to the other intersection point, that would correspond to angle 7. And then lastly, that leaves then angle 4, which corresponds to angle 8. So corresponding, again, we got multiple pairs here, but those are going to be any two angles that are in the same location at the different intersection points. All right, now let's look at the alternate interior angles. So interior angles are going to be the 4 angles between the 2 lines M and N. So we have angle 2, 5, 4, and 7. Alternating means that they are going to be on opposite sides of the transversal. Remember that this cannot be adjacent to each other. So let's say I choose angle 2. Angle 2, which is right here. Okay, alternate means it's going to be on the opposite side, but they cannot be adjacent to each other. So that means angle 2 and angle 7 would be alternate interior angles. That then leaves angle 4 and angle 5 as another pair of alternate interior angles. And again, if I look at the diagram, angle 4 is here. Alternate means opposite side, so on this side, but it cannot be next to each other, so that leaves angle 5. So those would be alternate interior angles. All right, then we are going to look at alternate exterior angles. So interior means between. Whoa, Nelly. Exterior means on the outside. So I have 1, 3, 6, and 8. So again, alternate exterior. Exterior means they're on the outside. So I have, let's start off with angle 1. But again, they cannot be next to each other. So I can't look at 1 and 3. Yes, they're on opposite sides, but they are adjacent. So instead, I'm going to go to the other intersection, point 6 and 8. And the angle that's on the opposite side of 1 would be angle 8. So angle 1 and angle 8 would be alternate exterior. And then that leaves, again, that's going to leave angle 3 and angle 6, 3, 6 Mafia, it's going down. That's going to leave those two as my other alternate exterior angle. All right, last one, we have consecutive interior angles. So the word consecutive, again, sassy, sassy, sassy. It's like if you were to win consecutive championships, that's back to back. The way I like to think of this as same side interior angles. So know that that's sometimes how I denote just to make it easier to represent. But interior angles, again, we have the 4 angles on the inside, 2, 4, 5, and 7. So alternate interior, the ones on opposite sides, and consecutive means the ones on the same side. So for example, if I were to choose angle 2 and angle 5 are on the same side of that transversal, as well as angle 4 and angle 7 are on the same side of that transversal. So this is just identifying these special types of angles. All right, I feel like I've talked for the last hour, so why don't you guys try 3 examples on your own. So here I'm just going to give you a pair of angles, 1 and 5, 2 and 7, 4 and 5, and I want you to tell me what type of angles they would be. Corresponding, same side interior or consecutive, alternate interior or alternate exterior. So pause the video, give this one a shot on your own. All right, real quick, but first one we had 1 and 5 would be corresponding. They're both in the top left corner of those 2 intersection points. 2 and 7 would be alternate exterior angles because they are on the outside of those 2 lines and they are on opposite sides of the transversal. And then lastly, this one's kind of tough because it was kind of squished, but 4 and 5 would be interior angles and they are on opposite sides of the transversal, so they are alternate interior angles. So if you guys got any questions, jot those things down. A lot of jargon, a lot of definitions, a lot of identifying. So if you got any questions, reach out. Otherwise, peace out. Thank you, guys. We'll see you next time.